Hello. This video is for the North Pacific Gyre robotic sampler, illustrating the first test in the Chesapeake Bay. First, I have just a brief segment here on the device itself. The device is encapsulated inside of a pelican case, supported by an internal aluminum frame. And as the camera pans over the various components, there is a peristaltic pump there on the bottom, followed by the red Arduino stack. The green board is a solid-state relay control board with one relay on it. And we now look at the tube mount with associated backlighting, and that is mounted to the optical bench. And you can follow the tubing there in the rear as it goes into the pump and out to the external environment. There's also a small netbook computer. It serves as the controller for the system. A battery pack. There is the FireWire camera and macro lens, and all of that is mounted to the optical bench with a custom mounting hardware. And there again is kind of the complete package, sealed up in a pelican case. My friend Dave volunteered to help out. He's got a pickup truck. We took a couple of kayaks and a large inner tube. And another friend, Katie.
All right.
Katie came with. She had a sea kayak.
Driving to the sandy point at a high rate of speed, about to veer off into the forest. With a large number of boats and other things in the trunk. And a large inner tube. Don't ask any questions. Here's Dave. Katie is all ready in her gear. And here is the device, just while there's no water in it. And sand. Katie's vesting up.
It was a beautiful day at the bay.
Katie is prepared. Unlike some people, she is prepared. Here's the device before we lose it in the ocean.
That blue sphere was a 15-pound weight.
Okay. Yes. Alright, wait. Get in. I'm going to tie this up, and then you can kind of carry this into the water.
Sorry about the shaky video footage. I had just been using a new camera.
Wow. Ready? Yep. Doesn't bounce on the bottom until we get out a little bit deeper.
Getting the device out in the bay was non-trivial, but we ultimately succeeded. I hope I didn't ruin it for you. You can see that the container had a slight downward pitch in it on one side. That was due to the 15-pound weight. And the reason we attached it was to make sure that the input and output ports stayed underwater for most of the time. That was the idea, at least, and it seemed to work. As you'll see in some footage shortly. Katie took some footage from the kayak, and you can see that the case was pitched downward slightly, and for the most part the ports did stay submerged. Dave and Katie stayed out in the kayaks for about 35 minutes. And again, it was a beautiful day. After the kayaks, Dave held the device with the ports underwater just for a few more tests. Here's some footage from one of those tests. You can see as the pump starts, the pump first evacuates some air bubbles from the tubing, and you can see then that the ocean water starts being pumped through and imaged. You can see another air bubble there. That tubing diameter is about 7/16 of an inch, so it's about half an inch tall, and the images are taken at 15 frames per second. As the video ends, you'll see that the water calms down a bit, and we will end with a few shots of Katie. So Katie has now mounted the kayak to her car and is now lashing it. It's as long, actually it is longer than her car. And she is. Yes, it is definitely longer. Quite a spectacle. There's Katie's car with her sea kayak attached. And with that, thank you for watching. This was for the North Pacific Gyre Robotic Sampler.